All right, folks. In this video, we're going to be taking a look at section 2.6, distance time graphs, in an exercise called Walk This Way. Typically, we would be excited to have you in the classroom working through this. However, you being at home, Mr. Bracken and I are going to have a little fun with this exercise. So, there's a little bit of predictions that's going to take place. If I zoom in here, you're going to see in the first case, a student walks away slowly from the CBR. You're going to be making a prediction on a distance from the CBR versus time graph as to what you think would happen. If you're going to walk away from the CBR slowly, distance from CBR versus time, Mr. Bracken's going to make a prediction as if he's in a student's mind thinking. Keep in mind that this is just a prediction, and we're going to be able to actually go through the exercise now and see what will happen utilizing the CBR and seeing this action in real time. So,
Mr. Smith, I'll take this and I'll blow this up to a bigger form so they can see.
Okay.
So my prediction was something like that. And again, this is the first one. Student walks away from the CBR. The student is going to be me.
All right, so as you can see on the table here, I've got a CBR, which is a motion sensor. It's going to be picking up Mr. Bracken's distance as he walks towards or away from the CBR. First case, he's walking away from, so I'm going to set this up and we're going to see how this looks. And on the calculator it says, point the CBR at target, press start, and here he goes. As Mr. Bracken's walking away from the CBR slowly, in real time, we're getting the graph of what's happening of distance versus time. So, as you can see, there's something that Mr. Bracken would have to fix from his original prediction. So what you're going to do on your graph is create the actual graph of distance versus time for him walking slowly away from the CBR. You'll notice he starts near the origin because the graph says distance from the CBR, and he was a little bit away from the CBR at the start and he walked slowly away. You can see how the straight line happened as he walked at a constant pace. Okay, we're going to now look at the second one. Number 2 says student walks towards the CBR slowly. Now that he's made the first mistake with his prediction, walking away, maybe he can get this prediction a little more accurate, walking towards the CBR slowly. Okay, so Mr. Bracken in this case is going to be, again, that was our old graph, walking towards the CBR. So he's going to start a distance away. And again, the CBR located on the table. I'm going to get the calculator set up here. And he's ready to go at this point. Now, as Mr. Bracken's walking towards the CBR slowly, you'll see the graph is happening here connected in real time. As he's walking again slowly towards the CBR, he's in motion. Excellent. This time, you'll notice that Mr. Bracken's prediction was a little bit better. But there's maybe something he could fix because of that slowly concept. Compare that one to maybe his prediction.
It doesn't look as steep, Mr. Smith.
That's right. So it looks like he's making his graph a little bit less steep because he was walking slowly. His movement was slow. Excellent. Let's go to the third one. Number 3, student walks very quickly towards the CBR. He's going to make his prediction. All right, and we're going to see how this looks. Again, Mr. Bracken will start away from the CBR. And I'm going to get this set up on the calculator again. As it shows, point the CBR at the target. So we're going to get going here, and he's going to walk quickly towards. Here he goes. He's moving quickly this time. Wow, look at that graph in action. So the rest of this we're not going to be too concerned about because the CBR is still in operation. It's picking up some random distances We were just worried about the first part. So let's go make our graph. And you're gonna see he gave a thumbs up there. He did a great job predicting. So it's a pretty steep line starting away from the CBR, walking towards. Number 4 says student increases speed while walking towards the CBR. Increases speed means he's gonna have to accelerate. That could be a little tricky to show acceleration because his first couple of graphs, he was walking at a constant speed. But when we're ready, he's gonna start really, really slow and then gradually increase his speed. Again, a prediction is gonna be made here by Mr. Bracken before we start. Okay, you can see we've got the prediction. We're gonna get into action here. And he's gonna increase his speed. Look how slow he starts. But he's gonna start to pick up his pace. And he's picking up his pace, and he's still picking up his pace. Look at that graph. Again, the rest of the graph is not too concerned because the CBR was still picking up. We have a curve. So, in this case, we had acceleration or increasing speed, and it was a curve. You can see that the graph gets steeper as we went on in time. Excellent. Number 5, student decreases speed while walking away from the CBR. All right. Decreases speed would mean he's going to decelerate. It'd be kind of like, if you're decreasing speed, kind of like a car where you hit the brakes coming towards a stop sign. Again, remember, his first graph is just a prediction as to what would happen. Remember, he's going to start close to the CBR this time, as he's going to be decreasing speed, moving away from the CBR. So when we're ready to go, I'll hit start. He's going to start now. Notice he starts very quickly, but then he's starting to slow down. What is this looking like on the graph? Mr. Bracken is slowly slowing down. As you can see, he's coming to a stop, and look at that graph. He started very quick and he slowed down gradually. So he did a pretty good job with his prediction. There was a curve. However, he's going to curve it the other way to have less steepness throughout the problem. And eventually at the end, he kind of came to a stop. So he started really quick, really steep at the beginning, slowed down, it got less steep as he decreased his speed, moving away. Excellent. Number 6. This is one where it's a little more specific. Student walks away from the ranger at 2 meters, stops for 5 seconds, then returns at the same pace. What we're gonna do here is we're gonna set up the scale for you. And I want you guys to think about what would happen with the prediction. So setting up a scale, he's using seconds on the time axis, going by a scale of 1. So every single grid line is worth 1 second. Good. The CBRs actually only take time up to 15 seconds, so this would work nice. And the distance from the CBR axis, the maximum range for these is about 5 meters total. So what he's going to do is just cover what we need, which is up to 2 meters, because it says here...
Want me to go to 5?
Sure, let's go to 5. Because when you look at the graph that's going to be created, it does go up to about 5 total meters. So we're going to cover that in our scale. So he's going by a scale, it looks like here, of 0.5, because every other grid line is 1 full unit. Okay, so we've got a scale of 0.5 on the distance axis. All right, now, you're going to think about a prediction here. Student walks away from the ranger, at 2 meters, stops for 5 seconds, then returns at the same pace. Okay, again, this is a prediction. We're now going to see this in action, walking away, stopping at 2 meters away from the CBR, then returning at the same pace. So we are ready to go now. So Mr. Bracken's walking away. He's stopping about 2 meters away. see the smartboard. He's counting 5 seconds and he's going to return at the same pace. Here he comes back, and let's take a look at the graph. Mr. Bracken is not only a good golfer, he can also walk towards and away from a CBR quite well. And this graph here, there's a slight change he's going to make to his original. As you can see in his prediction, he started walking away at a very nice pace, and he did stop for 5 seconds. However, Mr. Bracken thought that that line would come back to 0 when he walked back to the CBR. But in fact, the time continues on. Time doesn't stop. So, as he walked away, you can see stopped at 2 meters away for 5 seconds. He's counting the seconds from 5 to 10. That's a 5-second interval, and then walked back towards the CBR at the same pace. And you can see the steepness is about the same steepness as the first part of the graph, but the direction is different. The first part was walking away, up to the right, positive, and the second or last part, was walking back towards in a negative direction because he's going towards the CBR. Hope you enjoyed this video. We'll be talking to you guys real soon.